Alright, so this is the Chapter 23 demonstration on light spectroscopy. We're going to be using a computerized spectrometer. So Liz is behind the camera. Thank you, Liz. If you want to just pan over here, we're going to have this fiber optic cable. What this does is it takes in light and it's going to send that light into this computer spectrometer. And inside this, there's something called the diffraction grating that splits the light that comes into the fiber optic cable into its constituent parts. And then what we are outputting on the screen is going to be wavelength on the horizontal axis and then intensity. So I'm just going to point it at something in this room. So I'm going to point it at the, you don't have to pan, Liz, just keep it on the screen there. I'm going to point this at the fluorescent light bulb in the room, and you're going to see that we're going to get some output. Alright, so I'm going to point it at a few things. So I mentioned in Chapter 23, if you want to come back over here, Liz, I mentioned in Chapter 23 that the sun gives a continuous spectrum just like an incandescent light bulb. So that's what we have here. So I'm going to point, if Liz, you want to just get the light bulb. So there's the incandescent light bulb, right? So if you want to go back to the computer screen, this is what a continuous spectrum looks like. You're going to see that you have all wavelengths of light visible and a little bit in the infrared regions as well. So if you were to point this spectrometer at the sun, this is essentially the same output that you would get, just like an incandescent light bulb. All right. The next thing I'm going to show you is the spectrum of helium. You saw that in the PowerPoint presentation, so feel free to page through back to that slide. You'll actually see this exact same spectrum. So I mentioned in Chapter 2, you're going to have to go back a few chapters, that electrons orbit the nucleus of different atoms. Alright, now think about this. What would have more energy? Something that's really far away from the Earth, or something that's really close to the Earth's surface? Of course, if you're farther away, you're going to have more energy. The same thing goes for electrons. The farther they are away from the nucleus of atoms, the more energy they have. When those electrons spontaneously fall down closer to the nucleus of atoms, they give off energy. And they give off energy in the form of light. So what's happening in this demonstration is, right here we have a tube that's filled with helium gas. And what we're going to do is we're going to pass electricity through it. And what that does is that pumps electrons up to higher energy levels, and then they spontaneously fall back down to the lower energy levels, giving off light, and that's how we get the bright line spectrum I mentioned in the PowerPoint. So I'm going to point this here, and then if Liz pans over there, you're going to see that only specific wavelengths of light are emitted from that ionized helium gas. Alright, one last demonstration, and it's going to be talking about something that I didn't talk about in the PowerPoint yet, but it's this idea of fluorescence. So I'm going to show you what a green laser pointer would look like. So if you want to come down to the table, I don't know if you could see that very well, but this is a green laser. So if I point the fiber optic there, and then Liz pans over to the output of the spectrometer, you're going to see that I essentially get green light. Okay? But watch what happens. I hope the camera picks this up well. If you see this green light, right? Want to get a little closer to that, Liz? Let's see, that's pretty green. But see, when I pan over here, it's really hard to see in the photo, but it's essentially changing colors. They're green, and it's kind of looking a little yellow. So what I'm going to do is I'm going to point this at this new color, and you're going to see that you get that same large green peak, but now we have this huge, what looks to be a continuous-like spectrum in the yellow and red regions, and that's called fluorescence. And it's, again, just the transition of different electrons and different energy levels from higher levels to lower levels. Alright, that's the end of the Chapter 23 demonstration. See you later.